dear students, today we will solve exercise 3.5 from the textbook of CBSE board NCERT Mathematics of grade 6. So let's start exercise 3.5. Here we have the first question as which of the following statements are true. So let's check one by one. Here first I am taking these two sentences which are related to each other. So the first statement is if a number is divisible by 3, it must be divisible by 9. And the second statement is if a number is divisible by 9, it must be divisible by 3. So to check these two statements, we first know the divisibility rule for 3 and 9. So the divisibility rule for 3 is sum of the digits should be multiple of 3, and for 9 sum of the digits should be multiple of 9. So let's check these two statements with the help of example. Here I am taking the number 24. As per the rule, we have to find the sum of the digits. So let's add these digits. We are getting the sum as 6. And 6 is a multiple of 3 but not multiple of 9. Let's take one more example. Here I am taking the number 30 and the sum of these digits is 3, and 3 is multiple of 3 but not multiple of 9. So these two numbers are divisible by 3 but not by 9. Okay, so as from these two examples we understood that if a number is divisible by 3, there is no compulsory that it should be divisible by 9. So the statement is false. Okay. Now for the second statement, let's take one more example. Here I am taking the number 189. When we will find the sum of the digits, we are getting the answer as 18. And 18 is multiple of 3 as well as multiple of 9. Therefore, this number is divisible by 9 as well as by 3. Okay. And also we have one rule that if a number is divisible by another number, then it is divisible by each of the factors of that number. And we know that 3 is a factor of 9. Okay. Therefore, the second statement, that is if a number is divisible by 9, it must be divisible by 3. Because all the multiples of 9 are the multiples of 3. Therefore, the statement is true. Okay. Now let's check the next statement. Here also I am taking those two statements C and D, and both of them are related to each other. Therefore, I am taking both of them at a time. Okay. Now to check, the first statement is a number is divisible by 18 if it is divisible by both 3 and 6. Same way the next statement is if a number is divisible by 9 and 10 both, then it must be divisible by 19. So for this, we have a rule that if a number is divisible by another number, then it is divisible by each of the factors of that number. Now let's find the factor of 18, and those are 1, 2, 3, 6, 9 and 18. Here 3 and 6 is present, right? Therefore, as per this rule, the first statement is true. Okay. Now, for the second statement, let's write the factors of 90, and those are these many. Here also 9 and 10 is present, right? Therefore, as per this rule, the second statement is also true. Okay. Now, let's move to the next statement, that is fifth one. If two numbers are co-primes, at least one of them must be prime. So, to check this statement, let's write the example for the co-prime numbers. Here 9 and 10 are co-prime numbers, but both the numbers are composite number. There is no prime number between these two. Let's take one more example. Here I am taking 4 and 5. Here 4 is composite number, but 5 is prime number. Okay. So in this co-prime number 4 and 5, there is a prime number, but 9 and 10 are co-prime number, but both the numbers are composite number. So when we observe such type of examples, we understand that there is no compulsory to have one of the number is a prime. So the statement is false. Okay. Now let's move to the next statement. Here also I am taking the two statements which are related to each other. Okay. The first statement is all numbers which are divisible by 4 must also be divisible by 8. And the next statement is all numbers which are divisible by 8 must also be divisible by 4. So first we will check the first statement, that is all numbers which are divisible by 4 must also be divisible by 8. For this we will check the multiples of 4 and multiples of 8. When we look carefully at these two tables, we understand that the multiples of 8 are present in the multiples of 4. But all the multiples of 4 are not present in the multiples of 8. Right, see here, 12 is not present in the multiples of 8, 20 is not present, but all the numbers from the 8 table is present, right? Therefore, the first statement is false. Okay, because if the number, this 12 is divisible by 4, but it is not divisible by 8 because it is not a multiple of 8, right? Therefore, the first statement is false. Now for the second statement, all numbers which are divisible by 8 must also be divisible by 4. Now, if you look at this table, all the multiples of 8 are present in the multiples of 4. When we compare, we understand that this statement is true, as well as we have one rule that if a number is divisible by another number, then it is divisible by each of the factors of that number, and 4 is a factor of 8. Therefore, the second statement, that all numbers which are divisible by 8 must also be divisible by 4, is true. Okay, now let's move to the next statement, that is, if a number exactly divides two numbers separately, it must exactly divide their sum. So for this we have a rule that if two given numbers are divisible by a number, then their sum is also divisible by that number. So this statement is true. As per this rule, this statement is true. Okay, now we have one more statement, that if a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. Now these two statements are related to each other. In the first statement, they have told us that if the two numbers are separately gets divided, then the sum also should get divided. But here they are telling that if the sum gets divided, then those two numbers are also gets divided separately. Okay, for this we will take one example. Here I am taking the number 20. 8 plus 12 gives 20. Here 20 is the sum which we found by adding these two digits, two numbers. Okay. Now here these both numbers as well as this 20 are all of them are divisible by 4. But if we split this 20 as 7 plus 13, then this 7 and 13 are not divisible by 4, but this 20 is divisible by 4, right? 7 and 13 are not divisible by 4. So we can split this 20 as any number, as 5 plus 15. There also 5 and 15 are not divisible by 4. Therefore, we can't say that if a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately, is false. Okay, now let's move to the next. Here all the statements we completed. So let's write the true or false one by one. If a number is divisible by 3, it must be divisible by 9, is false. If a number is divisible by 9, it must be divisible by 3, is true. A number is divisible by 18 if it is divisible by both 3 and 6, is true. If a number is divisible by 9 and 10 both, then it must be divisible by 90, is true. If two numbers are co-primes, at least one of them must be prime, is true. False. All numbers which are divisible by 4 must also be divisible by 8, is false. All numbers which are divisible by 8 must also be divisible by 4, is true. If a number exactly divides two numbers separately, it must exactly divide their sum, is true. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately, is false. Okay, so here we completed our first question. Now we will move to the second question. Now Here the question is, here are two different factor trees for 16. Write the missing numbers. Okay. Now, how to build a factor tree, I have explained in my previous video. If you want to understand about the factor tree, you can go through that video. Link is there in the description. Okay. Now, here this 60 is root. Okay. And these are branches. And this is the tip of the branch. Okay, now here the tip of the branches are there. No, these numbers if we multiply, we will get the number which is present at the root place. So you can check it. 6 tens are give 60, right? So we have to write here the number such that if we multiply this number with 2, we must get the answer as 6. So, and we know that 2 3s are 6. Okay. Now, here also we have to write the number such that when we multiply it with 5, we must get the answer as 10. And we know that 5 2s are 10. Okay. Now, let's complete this factor tree now. Now, see here. 30, how much are 60? Yeah, everyone know that 30 2s are 60. So, here we will write 2. Now we have to find the number such that when we multiply it with 10, we must get the answer as 30. So we know that 10 3s are 30. Now we have to write here two numbers such that when we multiply both of them, we must get the answer as 10. So as we know, 5 2s are 10. Okay. So we completed the factor tree. Now let's move to the third question. It is the third question. Which factors are not included in the prime factorization of composite number? Yeah, it's easy. See here, whenever we write the prime factorization, we won't use the number 1 and that number itself, right? So, the answer for this question is 1 and the number itself. Okay. Now, let's answer the fourth question. The fourth question is, write the greatest 4-digit number and express it in terms of its prime factors. Means we have to find the prime factorization of 4-digit number, which is greatest 4-digit number. Okay. So let's write. To understand how to find prime factorization, you can go through my one-off video where I have explained about prime factorization, how to find prime factorization and what is prime factorization. Everything I have cleared in that video. Okay, the link is there in the description. So first we will write the greatest 4-digit number, that is 9999. Okay. So to find the prime factorization of 9999, first we have to write that number, then we have to draw a vertical line in front of that and horizontal line below that. Okay. Now we have to start from the first prime number, that is 2. Okay. So first we have to check whether the given number is divisible by 2 or not. For that we must know the divisibility rule. Okay, as we know that if the number is even number, then it gets divisible by 2. But here the number is odd number, so we can't use here 2. So the next prime number is 3. So here for 2, divisibility rule for 3 is the sum of the digits is should be multiple of 3. So let's check. 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. 36 is divisible by 3. So let's divide this number by 3. So if we have to write here the number 3. And first we have to check the first digit, that is 9. And we know that 3 3s are 9. Okay. Now we have to move to the next number, that is also 9. So again 3 3s are 9. Now the next number is also 9. So 3 3s are 9 again. Now again 3 3s are 9. Okay. Now again, now we got the new number, that is 3333. Okay. Now this is also an odd number, so we can't divide it by 2. The next prime number is 3, and clear we understood that it can get divided by 3. So 3 1s are 3. Okay, the next is 3. So 3 1s are 3 again. again 3 ones are 3, and again 3 ones are 3. Okay, now this number is not even, so we can't think about 2. Now we will get the sum as 4, which is not multiple of 3, so we can't think for 3. Now the next prime number is 5, as there is no 0 or 5 is present on unit place, so we can't think for 5. Next is 7. Next is directly we can divide this number by 11. Okay, so 11 ones are 11 first. Now 11 minus 11 is 0, so we have to move. Next is 1, as 1 is less than 11, so we have to divide this 1 by 0. Okay, 11 zeros are 0. When we subtract 0 from 1, we will get the remainder as 1. That 1 we have to write in front of the next number, that is 1. Okay, so we got the number as here 11. Okay, so 11 ones are 11 again. Okay, now here the number we got as, that is 101, and it is a prime number, so we will directly divide 101 by 101. So 101 ones are 101. So the prime factorization of 9999 is 3 into 3 into 11 into 101. Okay, now we will move to the next question, that is fifth one. Write the smallest 5-digit number and express it in the form of its prime factors, same as the previous one. So let's solve it. So the smallest 5-digit number is 10,000. Okay, now let's find the prime factorization. First we will write the number. Now as this number is an even number, so let's divide it by 2. 2 5s are 10. Okay, now we will move to the next digit, that is 0. So 2 zeros are 0. Now for this 0, 2 zeros are 0 again. Now for this 0, again 0. Okay, now this is also an even number, so again we can divide it by 2. So 2 2s are 4. Now when we subtract 4 from 5, we will get the remainder as 1. That we will write in front of the next number. So we got the number as 10. Okay, now we know that 2 5s are 10, right? Now the next is 0, so 2 zeros are 0, again 2 zeros are 0. Okay, now this number is also an even number, so let's divide it by again 2. 2 ones are 2, right? The next number is 5, so we have to divide it by 2 only. 2 2s are 4. Now when we subtract 4 from 5, we will get the remainder as 1. That we will put in front of this 0. So this became 10. So 2 5s are 10. Now for this 0, 2 zeros are 0. Okay, again we got the number as even number. So let's divide it by 2 again. 2 6 are 12. Now the next digit is 5. So 2 2s are 4. Now we got 1 as remainder because 5 minus 4 gives 1. So that we will write in front of this 0. So this became 10. So 2 5s are 10 again. Now this is an odd number. So we have to think for the next prime number, that is 3. Let's check by adding these digits. 6 plus 2 is 8. 8 plus 5 is 13. And 13 is not multiple of 3. So we can't take 3 here. So we will move to the next prime number, that is 5. As here the 5 is present on unit place, so we can divide it by 5. Okay, so 5 ones are 5. Now when we subtract 5 from 6, we will get the remainder as 1. That we will put in front of this 2. So this became 12. 5 2s are 10. Now when we subtract 10 from this 12, we will get the remainder as 2. That we will put in front of that 5. So this became 25. 5 5s are 25. Okay, now again we got the number which has 5 on its unit place. So let's divide this by 5 again. So 5 2s are 10. And now we got the remainder as 2. Okay, so that we will put in front of that 5. So this became 25. So 5 5s are 25. Now 25 is 5 5s are 25, right? Now we got 5. So 5 ones are 5. Okay, so the prime factorization of 10,000 is 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. Okay. So let's move to the next question, that is 6th one. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. Okay. So first we will find the prime factorization of 1729. Okay. So 1729, as this is an odd number, so we will think for 3, okay, directly. So 7 plus 1 is 8 plus 2 is 10 plus 9 is 19. So and 19 is not multiple of 3. So we skip the 3. Next prime number is 5. As here 9 is present on its unit place, so we can't think for 5. Next is 7. So let's directly divide this by 7. 7 2s are 14. Okay. When we subtract 14 from 17, we will get the answer as 3, which we will write in front of that 2. So this became 32. Now 7 4s are 28. When we subtract 28 from 32, we will get the remainder as 4, which we will write in front of that 9. Then this number becomes 49. And we know that 7 7s are 49. Okay. Now this number, we got new number, that is 247 is divisible by 13. Okay, so we will get directly the number as 13. 13 ones are 13. When we subtract 13 from 24, we will get the remainder as 11. So the number became 117, and we know that 13 9s are 117. Okay. And we know that 19 is a prime number. So let's divide 19 by 19. 19 ones are 19. Okay. Now we got the prime factorization of 1729 is 7 into 13 into 19. Okay. Now what they told next is arrange them in ascending order. Yeah, we have already arranged it in ascending order. Okay. Now state the relation, if any, between two consecutive prime factors. Yeah, there is a relation between these two consecutive prime factors. That is, consecutive means next to the next number. Okay. So the relation between prime factorization of 1729 is the difference of two consecutive prime factors is 6. You can check it. See here, let's find the difference between 19 and 13 is 6, and 13 minus 7 also gives 6. Okay. So the relation is the difference of two consecutive prime factors is 6. Okay. Now let's move to the next question, that is 7th one. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. Okay. So here what they told, the product of three consecutive numbers is always divisible by 6. So first we will take the three consecutive numbers. Here I am taking three consecutive numbers are 2, 3 and 4. Okay. When we multiply them, we will get the answer as 24, and we know that 6 4s are 24. Therefore it is divisible by 6. Okay, let's take one more example. 11 into 12 into 13. Okay, when we multiply three of them, we will get the answer as 1716. And 6 into 286 gives us the answer as 1716. Therefore, it is also divisible by 6. Therefore, this statement is correct. Okay. Now, let's move to the next question, that is 8th one. The sum of two consecutive odd numbers. Now, here they have told us to find the sum of two consecutive odd numbers, and they are telling that it is divisible by 4. Verify the statement with the help of some examples. Okay. Some children don't know about consecutive numbers. Consecutive numbers means the numbers which is present next to that number. Okay. Now now they have told consecutive odd numbers means the number which is present, odd numbers which is present next to the odd number. Okay. So we will take the odd numbers, that is 3 and 5u. Okay, and they have told us to find the sum. So 3 plus 5u is equal to 8, which is divisible by 4. We know that 4 2s are 8. Therefore, 8 is divisible by 4. Let's take one more example. Here I am taking 11 plus 13 gives us the answer as 24. So 4 6 are 24. Therefore, it is also divisible by 4. Okay. So this statement is also correct. Now let's move to the next question, that is ninth one. In which of the following expressions prime factorization has been done? Everyone know that prime factorization means the factors must be prime numbers. Okay. And when we look at these four expressions, we understood that in the first expression this 4 and in this last expression the number 9, both are composite numbers, not prime numbers. Therefore, the number B, the expression B and C, here only the prime factorization is done. Okay, because all the factors are prime numbers. Okay. Now let's move to the next question, that is 10th one. Determine if 25,110 is divisible by 45. Okay. And they have also given the hint that 5 and 9 are co-prime numbers. Test the divisibility of the 5 and 9. Okay. So for this we must know the divisibility rule of 5 and 9, as well as we have one rule that if a number is divisible by two co-prime numbers, here the two co-prime numbers are 5 and 9, then it is divisible by their product also, and the product of 5 and 9 is 45. So for that only they have given here hint. And here I have given the divisibility rule for 5 and 9. The divisibility rule for 5 is the unit place should be 5 or 0. And for 9, the sum of the digits should be multiple of 9. Okay. So let's take the number first. That is 25,110. Let's check its unit place. The unit place has 0. Therefore, the number is divisible by 5. Okay. Now for 9, we will add the digits of this number. That is 2 plus 5 plus 1 plus 1 plus 0. Gives us the answer as 9. And 9 is multiple of 9. Therefore, it is divisible by 9. As the number is divisible by both 5 and 9, the number is divisible by 45. Okay. Now, let's move to the next question, that is 11th one. 18 is divisible by both 2 and 3. It is also divisible by 2 3s are 6. Similarly, a number is divisible by both 4 and 6. Can we say that the number is also divisible by 4 6 are 24? If not, give an example to justify your answer. Okay. Now, just we found that the rule, if a number is divisible by two co-prime numbers, here 2 and 3, both the numbers are co-prime numbers. Therefore, the number is also divisible by their product 6. Okay. But here, the number 4 and 6 are not co-prime numbers. Therefore, that number won't get divided by the product of 4 and 6. Therefore, the answer for this question is no. Okay. They have told us to justify our answer with the help of example. Let's take the example. Here I am taking the number 36 is divisible by both 4 and 6. Right. But it is not divisible by 24. 24 is the product of 4 6. Right. Therefore, the statement is false. Okay. Now, let's take the next question, that is, I am the smallest number having 4 different prime factors. Can you find me? Yes, we can find it. See here, they have told us that that number is the smallest number. Okay, so that prime factors also be smallest. Okay, so we will start from the smallest prime factor, and they have told us that they are 4 different prime factors. So let's start from the factors 2, 3, 5 and 7. So let's multiply them. As we know that when we multiply their factors, we will get the number. Okay. So 2 into 3 into 5 into 7. When we multiply them, we get the answer as 210. Therefore, the number is 210. Okay. Here we finished our exercise 3.5. If you have any doubt in any question, you can ask me in the comment box. I will clear that doubt. And if you have any, if you want I should create any video on any topic, you can tell me in my comment box. I will create the video. And if you like my teaching, please like, share and subscribe to my channel. Bye everyone.